In today's lecture, we'll talk about stack data structure. So it is also one way of storing the data. Let us look at how do you insert an element into a stack and how do you delete an element into a stack, the element from a stack, and so how do you store data in the stack. Okay, so here in this video we'll be talking about how to insert an element, how to delete an element, and basically we'll talk about these two algorithms and we'll try to explain what happens. So for this, for explaining the concept of stack, we require an array. So let us assume an array. So instead of following this notation of arrays, let us take it in a vertical way. So this is an array which you have, and array index starts from 0. And let us assume the name of the array is stack, and we have a variable called as top which is initially pointing to -1. Now I have to insert. So my first logic I have to insert the element at index pointed by top. So then I can also delete an element to which top is pointing to. Okay, so insertion and deletion takes place at the index to which top is pointing to. Okay, so here initial value of top is -1. That implies that there are no elements in the list for us. Okay, so stack is empty. How do you check this condition? Is top equal to -1, means stack is empty for us. That is the array which you want to insert the elements is empty. And how do you insert? What is the rule which we have framed? So these are the rules which we frame. So the rules which we frame is, I insert the element at an index. That index should be pointed out by top. So top will be pointing towards a particular index. At that index only I will be inserting an element. If I want to delete an element, so I can delete only that element to which top is pointing to. So to understand it clearly, so let us take an example. So assume this is a stack which is given to you, that is the array A. So that is, you have declared an array A, and the size of the array is 4 for you, and the initial value of top is equal to -1. Let us talk about insert function. So in insert you have two rules. First rule is, you before inserting an element you check if stack is full. That is, visually if you look at here, so you see the stack is empty. So we'll see what do you mean by stack is full condition. If stack is full, you cannot, that is if all the elements, all the memory locations are filled in this array, you cannot insert another element into this. So you say that if stack is full, you cannot do anything, you cannot insert a new element. You say return, or you stop the program. That is, you stop by saying that there are no memory spaces, there is no memory free space to insert into this array or into the stack, and you stop it. Else what you do is, if there is a memory space, the logic which you follow for inserting an element is, first you increment the top variable. After incrementing the top variable, you say that A of top is equal to whatever the element which you want to insert. Okay, so this is the logic for inserting an element into a stack. Okay, so now let us see how it works. Suppose if I want to insert an element 11, my first logic is I have to check whether stack is full or not. Visually you look at here, stack is empty for us. In a while, in a few moments we'll see what is this condition. So here if you see, Visually if you see stack is empty, so first condition fails. Come to the second part, that is health part. You increment top value. Top is equal to, here what is the top value initially? -1 plus 1, which will be 0 for you. Then you say that a of top is a of 0 is equal to 11. So what happens is top is pointing here now, top is equal to 0, and you say a of top is equal to 11 means 11 is inserted here. Similarly if you want to insert 12, the same thing, that is first step fails, that is I have some free memory locations. You come to the second part, you say that top is equal to, what was the previous value of top? 0. So 0 plus 1 is 1 for us. Then you say that a of 1 is equal to 12. So top is incremented and 12 is inserted for you. Similarly if you want to insert 13, the same thing, that is first condition fails, that is you have free memory locations. In your second condition you say top is equal to, what was your top previous value? 1. So 1 plus 1, which is 2. Then you say that a of 2 is equal to 13. So top gets incremented and element 13 is inserted for you. Now similarly if you want to insert an element 14, the same thing, first thing condition fails, that is you have free memory space, first condition fails. You come to the second one, you say top is equal to, what was your previous top value? 2. So 2 plus 1 is 3 for you. You say that a of 3 is equal to 14. So you increment the top variable and element 14 is inserted for you. Now if I want to insert an element called as 15, first thing I have to check is whether stack is empty or not. Here visually if you see stack is not empty, all the memory locations are filled. So your condition fails and your program stops. So now if you want to formally give a logic here, how do you check whether stack is full or not? So stack becomes full when top value is 3. So what is the size of the array for us? 4. So if top equal to 3 and n equal to 4, if you think of the logic, you can simply write a logic in this way. If top is equal to n minus 1, then you say that stack is full. That is, if top is pointing towards the third index and n value is 4, then stack is full, because array index starts from 0 for us. Okay, so if top equal to n minus 1, then you say that stack is full and you stop your program. So if you want to write a function for it, you say that void insert. So insert can also be called as push. Okay, so inserting an element into a stack is called as push. Both of them are same for us. So you say that void push, you want to insert an element, so you take it as an argument, then you check the condition. If top is equal to n minus 1, you say that printf stack is full and you cannot insert the element, and you exit the program. Else what do? The process which you follow is, first we increment the top variable, then we say that a of top is equal to the element which you want to insert. So this is your function for inserting the element. So this is your function for inserting the element, and if this is your program, so we have standard input output library, and we'll be declaring, for now assume that we'll be declaring the stack, whatever the stack which you want to have, globally, that is all the functions can access it. So this is your stack and this is your size of your array. Next, so we'll be calling it from the main program. So we say that in main, so I'll be simply calling it as, let us, what name of the function is push, so I'll be simply calling it as push of 15. So either the element 15 will be inserted or you'll be getting this stack full. So I'll be calling it as many number of times as possible, and if there is an empty space, element will be inserted for you. So this is how you insert an element into a stack. So now let us talk about how do you delete an element from the stack. So I have said that always we concentrate on top variable. Okay, that is we insert the element to which top is pointing to, that is we insert at the index where top is pointing to, we delete from the index where stack is pointing to. So let us take the previous example itself. In your previous example, so the stack size was 4 and these are the elements which you had. Okay, let us take that example itself. So the stack size was 4, so we had 13, 14, 15, 16, 0, 1, 2 and 3, and n value was 4 for you, that is size was 4, name of the stack was this, and top was pointing towards the third index. You have stopped at this point, so top value was 3 for you. So if you want to delete an element, first logic is you cannot delete from an empty stack, because if you look at an empty stack, if there are no elements inserted here, what was our initial condition? Top was initialized to -1. So when you start your program, top starts with -1, that implies that there are no elements in the list for you. Okay, so we check, how do you check whether a stack is empty or not? So this is how we check it, that is initially top will be initialized to -1. When we start our program, stack is empty for us. So if top is equal to -1, we say that stack is empty. So because that is our initial condition, if top is equal to -1, stack is empty, and you cannot delete from an empty stack, so you say that exit, you stop your program. Else what do you do is, you have only one statement which you have to write here. You simply say top equal to top -1, that's it. So this is your algorithm for deleting an element from the stack. That is, suppose if I want to delete, so always remember, in stack delete we always delete topmost element. So whenever you want to delete an element, you always delete the topmost element. You cannot delete, suppose top is pointing towards 16, you cannot delete an element called 13. Okay, that is the logic which we follow, that is the rules and regulations which we have set. That is, if you want to delete an element, you have to delete an element to which top is pointing to. If you want to insert an element, you have to insert at the index where top is pointing to. Okay, so that is the rules which we have set in the beginning. In another video we'll be talking about the motivation behind having this set of rules and regulations, but for now in this video you look at and remember that we always follow you remember this rule, that is you only delete an element, okay, to which top is pointing to, and if you want to insert an element, you insert at that location where top is pointing to the. Okay, so if you want to delete an element, obviously topmost element will be deleted. So first condition I will be checking is, if top is equal to -1, that is I am checking whether stack is empty or not. Stack is not empty because top value is 3 is equal to -1, condition fails for me. I come to the second step. I say top equal to top -1, that is 3 -1. Now top value is 2. So here now what will happen is, top is pointing to index number 2. So if you look at here, I am just changing the variable where I can insert and delete. I am not really deleting an element from a list. So practically also in your computers you don't have the concept of deletion. Whenever you want to delete an element, either it is overwritten by some new data or it is overwritten by some gen data. Okay, or you just forget about it. Okay, so you don't remember where the data is stored. So in real world computers also you don't have the concept of deletion. Just forget that there is data available. So what happens is, now you have one empty location. Okay, so suppose at this point if I say push of 4, that is if I want to insert an element called as 4, in my push condition, that is insert condition, what do? I check if top is equal to n minus 1. Now what is top value? 2 is equal to n minus 1 is 3. Condition fails. I come to the else part. In else part, what do? Increment top is equal to top value is 2 plus 1 which is 3. Then you say that a of 3 is equal to 4. Now what will happen is, this gets overwritten by 4 and top is pointing to the third location. That is again stack is full for us. That is, in this way you override the previously deleted values. Okay, so now again if you want to delete an element, the same thing. That is, if you want to delete, always you have to delete from the top. You can only delete the topmost element. What happens? First condition fails, that is top is equal to n minus 1. no, the stack is full, you can delete some elements. You immediately come to the second step, you say that top minus minus, so top is decremented to the previous index. Again if you call delete, top gets deleted to the first index. Again if you call delete, top gets deleted to 0th index. Again if you want to delete, top will be decremented to minus 1. Again if you want to delete, this first condition itself will satisfy, that is top is initialized to minus 1, condition satisfies, you exit the program. Okay, so now let us take another example. So assume this is the array which you have, and top value is minus 1 for you. So these are the some set of operations which has to be performed. So push off 5, push off 6, push off 7, and pop. So pop is also called as delete. So delete operation is also called as pop in your stack. Pop, then you say push off 12. So these are the instructions which you want to execute on the stack, and after executing this instruction, what are the resultant elements in the stack, you have to determine. So our first instruction is push off 5. Whenever we use insert function, so whenever I say push off 5, so first condition which I follow is when I check whether stack is full or not. Okay, so stack is empty for me, that is I'll be checking if top value, that is top value is minus 1, whether it is equal to n minus 1. So your n value is 5 for you, that is size of your array is 5, so is equal to n minus 1 means 4. Condition fails, you come to the else part. In your else part, you simply say how do you insert an element, you first increment the top value, top gets incremented. Okay, so previous value of top was minus 1, so minus 1 plus 1 is 0 for you. So you say that a of top, that is a of 0, is equal to element, what is the element which you are inserting? 5. So top is incremented and element 5 gets inserted. Next you want to push an element called as 6. Same thing, you check if top is equal to n minus 1, top value is 0 is equal to 4, condition fails. You come to the else part. In else part you increment the top is equal to, what was your previous value of top? 0 plus 1 which is 1. Then you say that a of top is equal to element 6 which you want to insert. So top will be incremented to 1 and element 6 gets inserted. Next you want to insert an element called as 7. Same thing, you check if top is equal to n minus 1, top value is 1 for you, 1 is equal to 4. Condition fails, you come to the else part, you increment top value, top is equal to, previous value of top was 1, so 1 plus 1 is 2 for you. Then you say that a of top is equal to 7, the element which you want to insert. So top will be incremented and element 7 is inserted to you. Okay, at this point now you want to delete some element. Okay, you cannot delete some element, you only delete the topmost element. Okay, so here if I say pop, whenever I call this function pop, topmost element will be deleted. So always remember, whenever I call the delete function, topmost element will be deleted. Okay, so whenever I call for top, here 7 has to be deleted. So according to our logic, we have to check whether stack is empty. If stack is not empty, there are some elements, you have to just decrement the top variable. That is the logic which we had. So according to our first logic, I am calling the pop operation. I am saying that I am checking if top is equal to minus 1. What is top value for me? Index value 2. 2 is equal to minus 1. Condition fails. I come to the else part. In here else part, what do? I say top equal to top minus 1. Top value is 2 for me. 2 minus 1 is 1. So top gets decremented and it is pointing towards index 1. Okay. Now the same thing. So now second pop operation. Now again if I call the pop operation, topmost element will be deleted. Okay, same thing, I'll be checking if here now top value is 1 for me, 1 is equal to minus 1, condition fails. I come to the second statement, I decrement the top variable. So top variable is pointing towards now 0th index. Now again I say push operation. So again push operation means the same condition, I have to check whether stack is full or not. What is top value for me? 0 is equal to n minus 1 value is 4. Condition phase, I come to the else part, top gets incremented, top value is 0, now top is pointing to 0, right? So 0 plus 1 is 1 for me, then I say a of top, that is a of 1 is equal to 12 elements. So what will happen is 6 gets overwritten by 12. Suppose if I again call push of 13, same thing, I have to check, that is I am calling push of 13, I have to check the same thing, that is if top is equal to n minus 1, top value is, now top is pointing towards index 1, so 1 is equal to 4. Condition phase, I come to the else part, first I increment the top, top gets incremented to 2, then I say a of 2 is equal to 13, so 7 gets overwritten by 13. So if you look at this example, previously what happened is you first inserted 5, 6 and 7, and once if you delete the element, so which element gets deleted? The topmost element. What is the topmost element? The reset element which was inserted into the stack. So stack follows a condition, that is, so stack says that stack follows this kind of last in first out. So last in first out. So element which is inserted last is the element which is deleted first. So here in these 3 elements, what was the element which was inserted last? 7 was the element which was inserted last. And if you call delete function, which element will be deleted first? The previous last element which was inserted, that is 7. Next, if you call the delete operation, what will happen? The second last element which was inserted will be inserted, that is last in first out. Okay, so whatever the element which gets inserted last will be the element which will be deleted first. Okay, so it is similar to a stack of plates, that is if you have a container, in this container if you place all the plates, okay, and if you want to again remove all these plates, so which plate will be removed first? The plate which has been inserted last will be the plate which will be deleted or which will be removed first. In this way removing the plates continues. In another, if you have to look into the another video where we'll be talking the motivation behind having such kind of restrictions and such kind of insertion and deletion policy. Why do we have it and why do we follow it? We'll be talking in another video.